Okay, good evening, everybody. So today we're going to be talking about section 9.8, which is factoring quadratics completely. And a couple of students have started to notice or see this on their own, and were wondering if they could do it. And I told them that it was going to be coming soon. So today is that day. This is a task or a skill that you want to be looking for first. This is one of the very first things that we do when we're talking about factoring. If you do and you get good at it, it makes a lot of your factoring much, much easier. So we're going to go back and we're going to talk about some of the different terms. So if we recall, this one here is called the A, this term is called B, and that term is called C. So the coefficient on x squared is the A term, the coefficient on x is the B term, and the constant is the C term. So whenever I look at a quadratic, if A does not equal 1, okay, so if A, oh, let me say real quick here, this is going to be my green, for those of you who are keeping track, and this is going to be my blue today. I can't remember if these are the same ones I used yesterday or not. So that's green and that's blue. Okay. Whenever the A does not equal 1, that's when we want to think about factoring completely. Okay, so anytime I have an A value other than 1, I think about factoring completely. So what I have here, I see, all right, I've got A does not equal 1, A equals 2. So I want to think about factoring this completely. So here's what we do. We're going to use, big surprise, we're going to use generic rectangles. So I'm going to put a big, long generic rectangle, and the generic rectangle we factor completely is going to be a one-story, in this case, 3-bedroom generic rectangle. One thing I'd like to point out is notice where I put the sign. The sign goes with the term behind it. The sign goes with the term behind it. So I made sure that this stayed positive 10x squared and this stayed positive 12. Alright, so next what I want to do is I'm looking for something that I can put on the wall right here that will multiply into each one of these. So I see I have a 2, I have a 10, and I have a 12. And what's in common to all three of those? I'm sure we have already said it in our head, if not out loud, a 2. So then 2 times what gives me x squared? Well, that of course would be x squared. And 2 times what gives me 10x? Well, of course, that would be 5x. And 2 times what gives me 12? That would be 6. So what I have now then is 2 times x squared plus 5x plus 6. Hopefully at this point you're starting to recognize that quadratic because I've used it several times. Look back in your notes, I've used it a lot. It's one of my favorite quadratics. And so it is factorable. So then we can go diamond problem. And first of all, I check to see if this is a perfect square trinomial, and I see that it is not because I do have a square root of x squared, but I don't have a square root of 6. So since I don't know the square root of 6, I have to do the diamond problem. So on the top I get 6x squared, on the bottom I get 5x, the left I get 2x, the right I get 3x. Now I do my generic rectangle. In the first box I put x squared, in the last box I put 6, and the other two boxes I put my 2 wings. So on the outside of my generic rectangle I'll get x times x plus 2 plus 3. I'm sure I'm not teaching anything on that last part. You've been doing generic rectangles for a while. The reason I did it all the way out because I do want to show you what the final answer is. The final answer, of course, is going to be x plus 2 times x plus 3. But remember that this, right here, when I multiply this together, has to be equal to this. And this will not be equal to this. This right here will be equal to this quadratic, not this quadratic. So what's the difference between this one and this one? I multiplied by 2. So what you have to make sure you do is bring whatever you factored out first. The thing you factored out completely has got to be in front. So 2 times x plus 2 times x plus 3. This is your final answer. If you don't include the 2, ladies and gentlemen, I regret to tell you, I cannot give you full credit. Anything you factor out has got to be in your final answer. Okay, let's take a look at the next example. Should go quicker. Alright, so we got the same thing here. We see we have a quadratic. This time I got all these y's in there and I don't like it. I'd rather have x squared and nothing else. or x's and nothing else. So I do notice though that I like that I have that. So here's my a term, and my a term is not of a 1. So I immediately think, man, I hope I can get rid of that some way. What I notice is each one of these have a y in it. Since each one has a y, that means I can factor completely. So I'm going to draw my generic, excuse me. I'm going to draw my generic rectangle. And again, when I draw it, I make sure that the signs stay with the term behind it. And I'm looking for something that goes into all three of these that's in common. And what I notice is that I have a y here on all three of them. So y times x squared gives me x squared. Y times negative 9x gives me negative 9xy. And y times 20 gives me 20y. So now I have this, which is y times x squared minus 9x plus 20. And I immediately look to see if I can take a shortcut on this when I see that I cannot, because this is not a perfect square. Since that's, whoops, I didn't mean to do that. Since this number here is not a perfect square, even though that one is and that one is, those don't matter. This has to be as well, so then I can't do it. So then I have to do generic rectangles. So I'm going to go like this, and on top I get 20x squared, and the bottom I get negative 9x. So I'm going to have negative 4 and negative 5x. My generic rectangle gives me x squared 20, negative 4x, negative 5. So I get x minus 4 minus 5. So my factors again are x minus 4 times x minus 5. Again, I did that pretty quickly. But then you have to remember, whatever you factored out at the very beginning has to come down. So it's y times x minus 4 times x minus 5. You'll see why in just a minute, why that's super important to remember. So once again, this would be my correct answer right there. All right, take a look at the other slide. Now how is this one different? Well, this one's different because I have an equation, not an expression. The previous slides, I didn't have an answer, so that I couldn't do anything except for factor it. Since this one has an answer, I can go ahead and find exactly what x equals. So we should have an idea what we're going to do first on this one. What we don't like is we don't like that one of our equations is not, one side's not equal to 0. We've come a long way since the beginning of the year when you hated the number 0. Now you're looking forward to it. So I need to make one side equal to 0. So the easiest thing to do is subtract 3 from both sides. And what I get on the left-hand side is 18x squared minus 8 equals 0, which is exactly what I like. Now, my next thing is I'm going, ooh, sweet, I got a binomial. That means it's probably a difference of squares. So I try and take the square root of this number, and I see I don't know the square root of 18. So I don't even need to worry about that one. It has to be the square root of this number, and the square root of this number, and that number has to be subtraction, which it is, but I can't square root that number or that number, so therefore I can't do it. So then I say, oh, you know what I notice? I notice that my a term is not equal to 1. If my a term does not equal 1, then the next thing I'm going to try and do is a generic rectangle. So here's my generic rectangle. Now notice, on my generic rectangle, I did not include what? I did not include the 0. I only take the generic rectangle of one side. I only factor the left-hand side. I'm not changing the number. I'm just changing what it looks like. So what goes into both 18 and 8? And I say, I know that. That would be a 2. And 2 times 18 is 9. Excuse me, 2 goes into 18 9 times. So that's 9x squared minus 4. So what I have now is 2 times 9x squared minus 4 is equal to 0. Don't forget your equal to 0. Now I go, oh, this looks a whole lot better because I have a binomial. I have subtraction, and this is a perfect square, and this is a perfect square. So that means I can use a shortcut. So I'm going to take the square root of the first term, which is 3x, square root of the last term, which is 2, and make 1 plus and 1 minus. And then making sure I bring down my 2. And the next thing, of course, we need to do, because we have an answer here, since we have an answer over here, I need to finish. I need to change this into two problems. So I'm going to go like that, like we've been doing before. So I have 3x plus 2 equals 0, and 3x minus 2 equals 0. Solve those, and x is going to be equal to, and for this one, negative 2/3, and x is equal to positive 2/3. So my answers for this one is right here. Notice here I don't have to include this number because they didn't ask me what the factors were. They're asking me what does x have to be equal so that this whole side will equal 3. If I plug in negative 2/3 up here, the whole thing will equal to 3. If I plug in 2/3 up here, this whole left-hand side will be equal to 3. So this is my answer here, not including the number I factored out. All right, last example. Looks like this, and you're going, holy mackerel, what the heck? That doesn't make any sense. Oh, sweet. Actually, probably right now you're going, yay! I only worry about quadratics, and a quadratic has x squared and nothing bigger. I don't have to worry about this one at all because that's got way too big of factors right there. So I'm done. And you're just going to write down on your thing, not possible because I am dumb. Right? That's what you're going to write. Well, while that may be true, that's not what we're going to do today. Sorry. You're going to learn how to do this. It's not that big a deal. You got it. You actually know everything you need to do. You just got to apply it to this problem. So here's what we're going to do. Take a look at this one. And this time we see our lead coefficient. You're going, oh, but it's not 1. My A is equal to 1. Whoops. A is equal to 1 right here. Why am I not writing? A is equal to 1. But remember that this is not a quadratic. So we only use A, B, and C when it's a quadratic. So I have to do something a little bit different. So what I'm doing on this one is I'm really looking and I'm noticing, you know what? I have an x here, an x here, and an x here. That means all three of those can be multiplied by some power of x. I want to get rid of that. I don't like it. So you're going to draw a generic rectangle. Notice that I did not include the 0. I only did the left-hand side. And then I'm going to make sure that when I do this, I keep the signs with the number after. Now, what goes into all three of these? What is the same in all three of these? And we see there's an x in each of them, which is true. But I noticed that even more than that, I have an x squared. There's an x squared here. There's an x squared inside of x cubed. And there's an x squared inside of x to the 4th. So I can put an x squared on the wall. And then on the bottom, what times x squared gives me x to the 4th? Well, that's x squared. What times x squared gives me negative 2x? Well, or 2x cubed would be negative 2x. And this one would be 35. So now what I have is x squared times x squared minus 2x minus 35 is equal to 0. So now I go, all right, well, I can't do the special quadratics because this right here is not a perfect square. So therefore I'm going to generic rectangle and diamond problem. I'm going to fast forward on this and just tell you what it is. You're going to do these two things. If you do those two things, you're going to come up with x minus 7 times x plus 5 is equal to 0. Okay, now here's where it's super important that you don't forget this term. Okay, on the previous slide, that term didn't really matter. For this slide, it does matter because that term is a variable. So I'm going to put that right here. And what I see I have here, if I'm actually gonna do it a little bit different than that. And I don't always write it like this, but for emphasis, I will. I'm going to write it like this. X squared, and put it inside parentheses. So this says this number times this number times this number is equal to 0. If I want this whole left-hand side to be equal to 0, that means I have to make one of these parentheses equal to 0. So normally what we do is we just take the two red ones and we separate them into two, and then we solve and we find our two answers. What we're going to do on this one is we're going to separate it into 3. I have x squared equals 0. I have x minus 7 equals 0. And I have x plus 5 is equal to 0. So because I have three terms, or three factors that have an x in them, I'm going to have three different problems to do. Now, the first one's not that big a deal. X squared equals 0, that means x has to be equal to 0. This one I see that x has to be equal to 7, and this one x has to be equal to -5. So, this right here is my answer. The reason I have answers for it, x is equal to a number, is because originally in the problem they gave me an answer of 0, so then I can solve it down here. So this is my final answer right here. Okay, so that is simplifying completely, and we use it when we have a term that is not equal to 1. Anytime you have an a term that's something other than 1, then we're going to use factoring completely. Okay, that's it, and I will see you guys tomorrow.